in or we need to put out. So looking at this thing here, this is very easy. There's only two numbers that they give us, which is again, the amount and the probability of that amount. So if you look at this thing here, they say in New York State number lottery, you pay $1 and pick a number from 000 to 19999, right? So which is again the same as us. We have pick 3. If you remember before all this thing here, if you know there's a pick 3, which is the same idea, right? If your number come up, you will win $500, which is a profit of $4.99. So again, if you lose, you will lose $1. Your probability of winning is 0.001. What is your expected profit? So looking at this thing here, remember I put here gain. You win 500 doesn't mean you gain 500. Okay, so again, the gain here is the profit, right? Which is again, you pay $1 to play the game. When you get back $500, you have to deduct your original $1. That's why this one here, they spell it out for you that the profit is $4.99. So looking at this thing here, hopefully you see that again, the gain here is we gain $499. The loss here, because we losing because of the loss, we have to put a negative number to illustrate that is a loss. Okay, so everybody see right here, this is the two number that you need to identify most of the time is what is my profit and what is my loss if there is a loss. Okay, and in this case, because you pay $1 to play, you will lose $1 if you don't win, right? So again, $4.99, which is they spelled out, that's your profit, that's your gain, and your loss is the lose, which is again -1 because of a loss. And now, what's the probability? Everybody see why the probability is 0.001? Everybody know why the probability is 0.001?
Because you spent $1?
No. Yes, $1. But you spend $1, meaning you buy one ticket. The total ticket from 000 to 999, there is 1,000 different tickets. Okay, and that's why the probability they give you 0.001 is basically 1 over 1,000. 1 over 1,000. That's why this is the 1,000th, right, percent of winning, not percent. Probability is 1,000th win, right? If you move it, it's 0.1% of winning. So because you pay $1 to buy one ticket, the total ticket that they can generate is 1,000 tickets. And that's why 1 over 1,000 is 0.001. Okay, so that's why. And again, if the probability of winning is 0.001, what is the probability of losing? What is the probability of loss here? Which is, do you agree that 1 minus 0.001 is the rest, right? Which is 0.999, right? Which is, if you add this together, the total probability is equal to 1. So everybody see that? Which is, if they give you one probability, you can find the other probability by take 1 minus whatever they've given us. Okay? And now, do you see that we have the table we needed? We have an X, which is your L1. We have the P of X, which is your L2. And my finger happy, I click it early. But again, everybody see that my X is this item and my P of X is this item. And now looking at this thing here, if you type in your calculator, which is now, everybody see that we can use our calculator, which is again, given this item here, I can use my calculator in the sense that again, I go stat. And reminder for those of you who want to clear your data, you have to click clear, do not click delete. So again, if I want to clear my data, I click clear, which is everybody see, I clear this, which is now all you need to do is type in 499, enter negative, make sure you use the negative symbol down here, not the minus sign, -1 equal. And again, this thing here will give me 0.001 and 0.999. So again, those are the two information I have, which is again, the amount I win, the amount I lose, the probability I win, the probability I lose. And then I go to calculate, which is for this one here, I need to hit let me clear it, make it. So again, if I go in, I have to hit L1, comma, L2. So again, looking at this thing here, hopefully, you know, this is the third time we're doing this, and hopefully you guys see that, oh, all of this thing here is very redundant. And yes, it's very redundant in the sense of that. So this one here, they ask you for expected value. So we don't care about the standard deviation. We don't care about anything here. We just know that the expected value is -0.5. What does mean -0.5? Meaning again, that's 50 cents on a dollar. Meaning again, you should expect to lose 50 cents on each dollar that you spend on this game, this lottery ticket. Okay, so basically in the long run, the New York State will take 50 cents on a dollar for this particular lottery ticket. Okay, so again, that's what the expected value is. Okay, so again, because it's negative, we expect to lose, right? We expect a loss. Okay, you know, occasionally, right? Occasionally you will win, but again, in the long run, you will lose 50 cents on each dollar. Okay, so again, question on how I have this answer as -0.5, and again, that's where the mean comes from. If you have question, and again, the most challenging part for this problem is not the answer, because the answer is just from your calculator. The most challenging part of this thing here is how do you determine your amount and your probability. And you know, some problem they spell it out for you. The last problem that we go over is that not really much spelling out for you. But again, question with this thing here, question with your calculator, or question with the answer here and how to interpret your answer.
Mr. Tran, can you just explain how the P of X equals 0.001? I just got a little confused right there.
They give it to us. Your probability of winning is 0.001. So again, if you win, how much do you win? Well, if you win the 500, but your profit is 499, right? So they tell us that your probability of winning is 0.001, right? And again, I just go in further and tell you how they have this probability is because there's 1,000 tickets and you buy one ticket. But again, they give you the probability here. So that's where the 0.001 comes from, is what they given to us.
And then the P of X of 0.99.
You will take 1 minus this, the leftover of this.
1 minus 0.001?
Right.
Okay, I got it.
All right. So let's take a look at another one, right? This is the first time you see this problem. And again, identically similar problem. It's just that now a different number lottery, right? Again, the setup is the same. The setup or the language is the same, right? So again, this is it's not a pick 3. It's just a different kind of lottery ticket, and you have a different amount of winning, right? So looking at this thing here, they say that you pay $1, still you pay $1 and can bet on the sum of the number that come up to be 13, right? So whatever this game is, we don't care. We don't care the game. They give us that, okay, if you pay $1 and you bet on that whatever this thing come up to be 13, you will win. If it doesn't come out 13, you will lose, right? And they tell you that the probability of winning is 0.075. Right? So we know the probability, that's what we have, or that's what they give us, right? We know the probability here. And now they ask us, and they give us, again, this is your probability, that's your P of X for winning, right? The probability of winning. If you win, you will win 650. But again, remember, we are not looking for the winning because we're looking for the profits, right? The winning is 650, but again, you spend $1, so you have to deduct that dollar out, right? So again, that's why the profit is only 550. So again, if they tell you that the profit, that's the number that you will use. If you lose, you will lose $1, right? So as you can see, very standard structure, which is the same as before, which is you need the amount, which is again, do you see that the amount is, we have 550 and we have a -1. Why? Because the loss is in negative, which is again -1 here, which is we minus $1 if we were to lose. Okay. And again, what is the probability of P of X? What is the probability of winning here? Well, the probability of winning here, they give us different, which is the probability of winning is 0.075. And if the probability of winning is 0.075, what is the probability of losing? Well, to find the probability of losing, I just take 1 minus the probability of winning, then I will see that I have the probability of losing, which is the probability of losing is 0.925. Everybody agree on this number here, or everybody see where I got this 4 number?
Yes.
All right. And again, hopefully, once you have this 4 number, now to find expected value, all you need to do is use your calculator to calculate it for you, right? Save the time instead of, again, you can multiply this over, and add them up if you want to. But again, you can save the time, plug this thing in your calculator, and L1 comma L2, which is, again, if you were to do this, the odds against us a little bit further, right? This game is even worse than the previous game, right? The previous game, you only lose 50 cents on a dollar. This game, you lose 51 cents on a dollar, right? So again, you know, looking at this thing here, you say, oh, mostly this game, so again, let's go, before I go into detail of this item, question on how I got the 0.51, negative 0.51. So everybody got the negative 0.51.
Yes.
0.51 is the X bar on the calculator, correct?
Yes. Negative 0.51 is the X bar. I think it's like 0.512 something.
2.5,
right?
yes.
Yeah. So because we want to put in the dollar and cents, so we only use 2 decimal places. And I think your homework tell you that too. Your homework tell you 2 decimal places. But again, think in terms of this thing here, this game is mostly like a dice game. Like you have 2 dice, right? And well, no, not dice. Sorry, the dice 2 dice cannot add up to be 13. 2 dice, the 6 and 6 is only 12. But again, this game is something that come out to be 13, right? And the reason why this game is worse than the previous game is the amount of you winning is not that much, right? The amount you're winning is too small. Last time you win 500, even though the probability is lower. This one here, the probability is higher than the previous one, but the amount of you getting back is not as much as the other one. That's why this game you lose 1 more cent than the previous game. Okay, but again, the idea here is how do we find the expected value? And to connect us back, the expected value is basically the mean. And to find the mean, for now, hopefully you guys see that again, to find the mean, I just need to use the 1-4 stat, which is type in your data and then use your calculator to calculate. So let's take a look at this question here, which is again a little bit different, right? A little bit different in terms of there's more than just 2 items that we have. So this is what they have is again business projection. So looking at this thing here, you try to evaluate what you need to do, and if this happened, if that happened, if this happened, will you have a gain or a loss, right? So before you get into business, you have to if you are a business major, you do all that marketing and stuff. But again, looking at this thing here, this is what you come out to be, right? So an investor consider to invest in $10,000, start up a company. So you estimate that you have a probability of 0.25 in 20,000 loss, right? So again, off the gate, C expect that C will lose 20,000. And the probability of C will lose 20,000 is 25% or 0.25. The probability of winning, or the probability of C get a 10,000 profit is 20%. And the probability of C getting a $50,000 profit is 15%. And the probability of C breaking even is 40%. So now everybody see that now they give us 1 item, 2 item, 3 item, and 4 different items, not like the other one, win or lose, right? They say, okay, you might gain $50,000, you might gain $10,000, you might gain nothing, and you might lose 20,000 at the end of the day, right? So they ask us, what is the expected value? And like before, to find the expected value, we need two things, right? To find the expected value, we need two things. We need the X and we need the P of X. Everybody see that because of the loss, it's the 20,000 loss, right? And again, don't take this 10,000, don't take this 10,000, no, interrupt your thought, right? So again, this is, they spell it out for you, right? There's 20,000 loss, and what's the probability of 20,000 loss? Well, the probability of 20,000 loss is 25%, right? There is a 10,000 profit. Remember, profit, that's your gain, right? You will gain 10,000. Meaning, again, you know, if you put in 10,000, you win, you got 20. But again, 10,000 profit, because of the profit, that's the number we use, which is again the 10,000. There are 50,000 profit, and the probability of the 50,000 is this. And again, if there are break even, meaning zero, then again, this is 0.40, which is if you add all the probability up, it's equal to 1, right? And this is our probability distribution, right? So remember, this is what we have, which is, again, everybody see where my X, the amount, came from, and where my P of X, the probability, came from. And hopefully you guys see that, oh, they spell it out for me, right? This particular problem, they spell everything out, right? There's a loss, negative sign. There's the profit, positive sign, and the probability of each of them respectively, right? And again, once you have this chart, all you do is you plug into your calculator. Hopefully by now, you know that you have to press stat L1, L2, and stat again, calculate L1, comma, L2. And if you were to do that, which is again, do you agree that you will have, is 450 in profit? Do you have, is it 4,000?
4,500.
4,500, so 4,500 in profit?
Yes.
So my number is, they added my number. But again, 4,500. So looking at that, you know, hopefully now, like I mentioned, hopefully now you see that find the mean is very easy, right? It's all redundant, right? It's pretty much number crunching, right? So looking at this thing here, the second question is, would you advise the investor to make this investment? Well, if it's in profit, well, you know, it's not, you know, overall, you still gain something, right? In the long run, this is basically, in the long run, you will make a profit. And if in the long run you make a profit, then go ahead, right? Pretty much that's what the idea of this thing is. You assess, you do all your marketing, you do all your item, you put in all your expand and revenue back and stuff like that. And you say, oh, at the end, there's 45 in profit. Go ahead and invest, right? If it's come out negative and you say, oh, wait a minute, something wrong here, right? We shouldn't invest because it's come out to be a negative, right? So that's the idea of this expected value, is what are we expected in the long run, right? What are we expect in a long haul, okay? So question with this expected value, question on where I get my number and how I derive to this answer. And again, probably, hopefully you don't have the question of derive to the answer, because your calculator gives you that answer. You know, the hardest part of this expected value is to find a number. If you can find a number, the answer should be very easy for now, right? And beyond, it should be very easy. Question with this example here. So if you don't have a question, I have one more problem, which is totally off the script. But again, one more problem, like I mentioned earlier today, my goal for today is just go over Fitness 5.1. And then I will give the rest of the day and the rest of the weekend for you guys to focus back to chapter 4. and we will begin 5.2 on Monday. But anyway, let's take a look at this thing here. This is a little bit different, and the way that they structure and the way they ask us is a little bit different here. So make sure that when you see this problem, make sure that this one here is not the profit, right? It is not, if they don't tell you that the profit, or if they don't tell you the actual amount that you win in, and stuff like that, you have to deduct something to do it. But let's take a look at this thing here. The story is an insurance company sell a 1 year's term life insurance policy to an 80-year-old woman. The woman paid a premium of $1,500. If she died within 1 year, the company will pay $25,000 to her beneficiary, right? According to the United States Center of Disease Control and Prevention, the probability that the 80-year-old woman will be alive 1 year later is 95 or 0.9516, which is 95%, right? Let X be the profit made by the insurance company. Find the probability distribution and the expected value for the profit. So looking at this thing here, let me ask you guys, how much money does the insurance get when they sell this policy to this 80-year-old woman, right? So again, for this problem, they say let X be the profit made by the insurance, meaning again, it's not the woman that get the money, it's the insurance that get the money, right? So do you agree that the insurance get
$1,500?
$1,500, right? Meaning again, they sell this, they sign the document, the insurance company get the $1,500. Now, what are their loss, right? Do you agree that their loss, they do not lose the whole $2,500, right? When they pay out, if for unfortunate event, this woman die within a year of her policy, they pay out $25,000. But within that $25,000 that they pay out, do you agree that they took in $1,500 already? So when they pay out the $25,000, they not really pay out the $25,000, right? The $25,000 is included the $1,500. They just return the $1,500 back, right? That's what insurance is, right? You pay to hold, to hold that, right? So if the woman died within a year, they pay back $25,000, but they not really pay the whole $25,000 because they only pay $23,500 because again, the $1,500 is the original owner. So everybody see that right here, we need to deduct what their premium is.
So Mr. Tran, so basically you just subtracted 25,000 with 1,500 to get 23,500.
Yes,
Okay,
that's it.
I was a little confused. But
That's it. Basically, again, you just take whatever they pay out and minus the premium because the premium is the money that they get in, right? And now they give us the probability of the woman alive, right? The woman alive, meaning again, do you agree that if the woman alive, the company will gain this much, which is again 0.9516. That's the probability. After years, the woman's still alive, done. They have to sign another deal, right? They have to sell another premium. After 1 year, the woman alive, they took this 1,500, and the probability that they keep this 1,500 is 95/16. Everybody see that that's the probability they give us. And again, if this is the probability of the gain, how do I find the probability of loss? Which is all we do is we take 1 minus this item. We have the remainder, which is these two items have to be equal to 1. Okay. So everybody see where my number come from, because this is the hardest thing for this expected value problem. The hardest thing for the expected value problem is how can you analyze to get your information? Because clearly, or hopefully, right, not clearly, hopefully, after you got the information, you can find the expected value with your calculator, right? So you type in your L1 and L2, and everybody see that the mu or the X bar on your calculator is 290. Everybody have the 290.
yes.
Yes.
Again, basically they say that in a long run, right? In a long run, if they sell to a lot of 80-year-old women, right? If one person, if they sell just one person, then again, if C alive, after 1 year, they gain 1,500. If C unfortunately die within that year, then they will lose the 23,500, right? But basically, they tell you that in the long run, meaning if they sell a lot of policy to a lot of 80 years old women, right? Then they will gain $290. Basically, they took the money from the other women who are alive after a years, and they pay for the one that unfortunately died within a years, right? So it's not really their money. Is basically, that's why they have to sell a lot of premium, because they take off the other premium to pay the one that have, right? So again, that's how insurance work, right? They sell a lot of items, right? And just like car insurance, right? They have a, like for instance, there's an age group. The probability that age group, people calculate and they say, okay, within this age group, the probability of getting in the car accident within 6 months is this much, this much. Now they assess this and they say, okay, we can sell the premium at this much. And if that happened, if one person happened to have an accident, we still have other premium to cover. And that's where we are in the unfair advantage, because we don't have an accident, but we still have to pay for the other people that have accident. But again, that's how insurance works, right? Insurance is just a backup plan, right? It's pretty much you pay for the thing. Hopefully that doesn't happen, right? You pay car insurance, but hopefully that you won't get in an